My name is Leanne.
Hey, I'm Will.
Hi, I'm Jonathan.
And we are UpcycleAI. Our goal with this project is to reinvent the textile recycling process and improve its efficiency by incorporating robotic assistance via a robotic arm and a conveyor belt.
I focused on the finances and visited the Salvation Army.
I'm looking at this, it's dirty, it's out. I put it here for recycling. This is recycling because they can cut it and put it somewhere. This is really dirty, but it can be recycled. You see the neck? It's all dirty, so I put it here. Jacket. It's so filthy. And this.
Yeah, could you show me where it's filthy?
Yes, here it's
Wow,
filthy. Here, the neck for baby.
So now what are you going to do with that? You're going to throw it out?
Garbage.
That goes in the garbage, okay.
This is recycling again.
And so just to clarify, that jacket that you just threw in the garbage over there, what's going to happen with it?
It goes to the dump site, garbage dump site. It's really garbage.
Okay.
So after visiting the Salvation Army, we realized how much of an impact we could have with our idea, and now it's time to make a prototype. So for the last 2 months, I've been working on creating a virtual demo of our product, looking forward and hoping to model it for the next stage of the competition. We started with a base model from the Open Source Robotics Foundation, and then we're able to tweak and modify the arm parameters based on our problem context. The other hardware components of our product were the conveyor belt and the camera that would actually use Azure Custom Vision to classify the textiles as they were going through the conveyor belt. So now that we had the arm figured out, it was now time to figure out how to integrate it into the textiles. With the Azure Custom Vision, we were able to classify the textile by fabric type and color. Of course, based on the needs of our clients, we're easily able to expand and refine the number of bins or categories of fabrics. Once classified, the textiles continue onto the belt to be picked up by our robot. Knowing the velocity of the conveyor belt, the robot is able to use some simple kinematic equations to figure out at what time it needs to grab the textile and then put it into its corresponding bin. The main challenges that we encountered with the development of our robot was mainly how to figure out the path planning, so to understand how we were going to tell the robot to move, angle, and maneuver its parts.
I worked on the implementation plan. Basically, my focus is on the machine learning aspect, or in other words, how do we build the underlying mechanism of the project so that it actually works? Using Microsoft Azure Custom Vision, we can easily train a model to classify different textiles and their characteristics. So we're using both of the project types available in Custom Vision. Image classification used for the sorting. This determines whether or not the clothing is beyond recyclable or not, the type of fabric, and the color. Object recognition is used to identify where different articles of clothing are situated on the conveyor belt so that our robotic arm can pick up specific pieces.
The costs associated with our project stem from the robotic arm, the conveyor belt, and testing the rubber on the conveyor belt to make sure it's in compliance with IS 1891 laws. The actual square footage and costs associated with the raw materials were approximated after industry standard. Visiting the Salvation Army proved to be an eye-opening experience. We realized the sheer need for a product like this because the unfortunate reality is that very few donated clothes actually end up being reused or recycled.
Working on our prototype has been super exciting, and we're looking forward to the next steps.
We're really excited about our project, and we really hope we can continue to build towards a more sustainable future with UpcycleAI.